Hey, welcome to Draft Academy. My name is Mike. In this tutorial, we're going to look at some of the core concepts in relational databases. So we're going to talk about how we store information in relational databases, namely in tables. We'll talk about the different things about those tables. We're going to talk about things called keys. We're also going to look at rows and columns. We'll talk about how different tables can be related to each other and how we can define relationships between tables. So this will really just give you guys a full introduction into some of the core concepts of relational databases, which you can then apply when creating your own relational database using a relational database management system. So let's get started. Over here, I have an example of a table, and this is a student table. And so the student table defines specific information about a student. So up here we have the column names. So the student ID, the name of the student, and then the major. So I'm storing three pieces of information about each student, right? They have their ID, their name, and their major. So over here we have Jack, his student ID is 1, and he's majoring in biology. Down here we have Claire, her student ID is 3, and she's majoring in English. So all tables in relational databases are going to have two things. They're going to have columns and they're going to have rows. Now, columns are these vertical sections right here. So a column would define a single attribute, right? So we have our name column. And inside the name column, we have the names of all the students. We have the major column. Inside the major column, we have the majors of all the students, right? Makes sense. And then we have rows. And a row is an individual entry in the student table. So a row or a horizontal entry would represent a single student, right? So in a single row, we're storing the student ID, the name, and the major. So the columns represent a single attribute and the row represents an entry or an actual student. Whenever we're creating a table in a relational database, we always want to have one very special column, which is called the primary key. And a primary key is basically an attribute which uniquely defines the row in the database. So it's an attribute about a specific entry which will uniquely define it. So over here we have student ID, and you'll notice that I colored this in red and I also underlined it. And this underline is basically going to specify that this column or this attribute of the student is going to be the primary key. In other words, we can use this attribute to uniquely identify a specific row. So over here we have Kate, and she's a sociology major and her ID is 1, right? So we would say that Kate's primary key is 1. Now let me show you guys why primary keys can come in handy. So down here inside of these gold squares, I have two entries in this database. So we have two students, both of which are named Jack, and both of which are biology majors. Now, this isn't that, special of a case, right? You can imagine that in a school you might have two students with the same name who are the same major. But in this case, how can we differentiate between this guy and this guy? Well, we can use this primary key. So even though the name and the major of this row in the table are the same as the name and the major of this row, the student ID is different. The primary key is different. And that's the whole point of a primary key, is that the primary key is always going to be unique for each row in the table. So even if all of the attributes of the row are the same, the primary key won't be, and therefore we can differentiate between the two rows, right? So I could differentiate between this Jack and this Jack by referring to their student IDs. And so generally, whenever we have a table in a relational database, you always want to define a primary key. And a primary key can be anything. It can be a number, it could be a string of text, it could really be anything that you want, but it has to uniquely identify the specific row. So in other words, another row in this student table couldn't have a primary key of 2. So down here I have another example of a database table. This is a user table. So just like that student table, except it's storing information about users. So over here we have email, password, date created, and type. So email is going to be our primary key. You can see I put that in red and I also underlined it. And these emails are unique to each entry in the table, right? So fake mail at fake.co, no other rows in this table could have that exact email. And then over here, we're storing the password. We're also storing a date. So a lot of times in databases, you can store date values or time values. And then over here, we're storing a type. And so basically, whenever you want to store data, what you're going to do is define a table. So you're going to define, all this information up here, and then you'll just insert specific pieces of information into that table. And so over here, we have one more example of a database table, and we're actually going to be looking at this example as we go forward. So this is an example of an employee. So imagine that we had like a company database and we were storing information about employees. So we have the employee ID, which is the primary key. We're storing first name, last name, birth date, sex, and salaries. And we're storing all of this specific information about an employee. Now, I want you guys to notice the primary key over here. So employee ID, this is just some sort of random number that we've assigned to each employee, right? This employee's ID is 100, this employee's ID is 101, etc. And this over here, this employee ID, this is what we would call a surrogate key. And a surrogate key is basically a key that has no mapping to anything in the real world, right? It's essentially just, like in this case, a random number that we assign to an employee, right? So this employee, Jan, has an employee ID of 100, right? That doesn't necessarily mean anything. 100 is just a value that we're using to represent Jan inside of the database. And so we would refer to that as a surrogate key, which is just a type of primary key. Surrogate key is a key that has no mapping to anything in the real world. We can also have something called a natural key. And over here, you'll see that I have the same exact table, except instead of having employee ID, I have employee SSN. And SSN stands for Social Security number. So Social Security number is a number that we use here in the United States in order to uniquely identify each citizen. So in this case, we're using the Social Security number in order to uniquely identify each row in the table. In other words, we're using the Social Security number as the primary key of the table. And this is an example of what we would call a natural key. And this is a key that has a mapping or has a purpose in the real world, not just in the database. So a lot of times you'll hear people refer to surrogate keys or natural keys, and that's the difference. A surrogate key is a primary key that has no mapping to the real world, and a natural key is a key that has a mapping to the real world, just like Social Security number. So those are kind of the two different types of primary keys that you might see being stored. Another thing I want to talk to you guys about are what are called foreign keys. And a foreign key is basically a attribute that we can store on a database table that will link us to another database table. So over here, I have this same exact employee table, and then I also have this other attribute over here, branch ID. And you notice that I colored this in green. And this is what we would call a foreign key. And a foreign key stores the primary key of a row in another database table. So here we have our employee table, and I'm defining information about the employee. But let's say that an employee belongs to a specific branch in our company, right? So a company might have different branches, and we can store the information about what branch the employee belongs to inside of a foreign key. So the foreign key over here is actually a primary key inside of another table, in our case, a branch table. So let me show you guys that. So down here, we have this branch table in our database, right? So the branch is its own separate table, right? And we have, the branch has a primary key over here, which is 231, and the branch names are Scranton, Stanford, and Corporate. So this in itself is its own table, right? It's the branch table. And over here, we can define which branch a specific employee belongs to by referring to the ID, the primary key of the branch. So here, Jan Levinson, her branch ID is 1, which means she is in the corporate branch, right? Because branch ID number 1 is corporate. Michael Scott, his branch ID is 2, which means he's in the Scranton branch, right? So this number is mapping this row over here into this other table. And that's what a foreign key does. A foreign key is essentially just a way that we can define relationships between the two tables. So a foreign key is just a primary key of another table. So Andy Bernard, right, his branch ID is 3, which means he belongs to the Stanford branch. And so that's what a foreign key does. A foreign key allows us to link up or define relationships between tables, right? I could say that Andy belongs to the Stanford branch, and I can define that using the foreign key. And over here, you'll see on the branch table, I also defined another foreign key, which is manager ID, MGR ID. That would stand for manager ID. And now this is actually going to be a foreign key which connects branch to the employee table. So manager ID is going to be the ID of a particular employee who is the manager of the branch. So let's take a look at the Scranton branch. So the branch ID is 2, the name of the branch is Scranton, and the manager ID is 101. So let's go check it out. So over here in the employee table, employee 101 is Michael Scott. What that means is that Michael Scott is the manager of the Scranton branch, right? We were able to define that relationship by using these foreign keys. So down here, the Stamford branch, the manager is 102. If we come up here, we can see employee 102 is Josh Porter. So Josh Porter is the manager of the Stamford branch. Corporate over here, the manager ID is 108. So over here, we didn't actually include 108 over there. So obviously this isn't like, a huge table of employees, but the manager for the corporate branch would be the employee with the ID of 108, whatever that would be inside of this table. And so that's what a foreign key does. A foreign key is able to help us to define relationships between the tables, right? I can define which branch a specific employee belongs to by including the branch's ID as a foreign key in the employee table. Similarly, I can define which employee is the manager of a branch by including that employee's ID as a foreign key in the branch table. So that's really why foreign keys are going to come in handy. And it's also important to note that a particular table can have more than one foreign branch on it. So over here I have my employee table, right? And it's the same exact thing as we had before, but I also added another attribute or another column over here, which is super ID, and that stands for supervisor ID. And so what this is going to do is it's going to define who is the supervisor of a particular employee. And what's cool about this foreign key is it's actually relating back to the same table. So an employee can be a supervisor of another employee. So over here we have Angela Martin, right? Her employee ID is 103. And her supervisor ID is 101. That means her supervisor is the employee with the ID 101. So if we come over here, we can look, Angela Martin's supervisor is Michael Scott because Michael Scott has an employee ID of 101. So Michael Scott's super ID is 100. That means Michael Scott's supervisor is the employee with ID 100, which is Jan Levinson. So we can use this foreign key over here on the employee table to define relationships between employees. So before we defined the relationship between the employee table and the branch table, and now we're defining a relationship between the employee table and the employee table, right? And so what's cool about this is then basically inside of this table, right, we can tell what the different supervisor-supervisee relationships are, right? I can tell that Josh Porter's supervisor is Jan Levinson, and I can tell that Angela Martin's supervisor is Michael Scott. I'm defining that information by using a foreign key. All right, so let's take a look at another table. I actually added in another table down here. So over here we have employee, just like we had before. We have branch, and then we also have branch supplier. And branch supplier is another table that we can look at. So branch supplier would basically define who the suppliers are for specific branches, right? So we have these branches, maybe they're selling, a certain product, maybe they're selling like paper products. And the branch suppliers would define who are the suppliers for that branch. And you'll notice up here, the primary key actually consists of 2 columns. And this is what we would call a composite key or a composite key. And a composite key is basically a key that needs 2 attributes. So this key is made up of 2 columns, right? It's made up of branch ID and supplier name. So branch ID is actually going to refer to the specific branch, and supplier name is going to refer to the specific supplier, right? So we could say over here that Hammer Mill supplies paper to branch number 2. Right, so Hammer Mill supplies paper to Scranton. Uniball supplies writing utensils to branch ID number 2, which is Scranton. Patriot Paper supplies paper to branch ID number 3, which is Stamford. So inside of this branch supplier table, I'm able to define which different suppliers are supplying what to which different branches. Now, the reason that I need this composite key or this composite key is because The supplier name doesn't uniquely identify each row, and the branch ID doesn't uniquely identify each row. Only together can they uniquely identify each row, right? So for example, supplier name Hammermill. You'll notice that Hammermill shows up here and it also shows up here, right? So Hammermill supplies to branch number 2 and they also supply to branch number 3. A Uniball supplies to branch number 3 and Uniball supplies to branch number 2. So this column has repeated values, right? This column has Hammermill repeated. It has Uniball repeated. Branch ID also has those things repeated, right? So branch ID 2 shows up here a bunch of times. Branch ID 3 shows up here a bunch of times, right? And so the branch ID column can't uniquely identify the table, and the supplier name column can't uniquely identify the table. Only together can they uniquely identify it, right? So we would say Hammermill supplies branch 2. That combination only shows up once, right? We wouldn't put that combination again because we're already defining it. So Hammermill supplies branch 2, Hammermill supplies branch 3. These two rows are uniquely identified by the supplier name and the branch ID. And so over here in these employee and the branch table, we only defined one column as the primary key, but over here we define 2 columns as the primary key, which is be a composite key. And that's actually pretty common, where we're gonna have 2 columns uniquely identifying each row. All right, so down here, I want to show you guys one more example, and this is going to show you one other way that we can define like different relationships with these tables. So I actually added in 2 other tables. We have a client table and we have this works with table. So let me kind of walk you guys through this a little bit. We still have employee, we still have branch, but over here we're defining clients. And so a client might be like a customer, right? So a client would buy paper products or whatever products from the branch and employee. Right, so the client has a client ID, they have a client name, and then they also have a foreign key, which is a branch ID. So a client is going to be associated with a specific branch, right? So we would say Lackawanna County is associated with branch 2, which means Lackawanna County is going to buy products from the Scranton branch. The John Daly Law LLC is going to buy products from branch ID number 3, so they're going to buy products from the Stanford branch, right? So this is a client table. And down here, we have this works with table. And what the works with table is doing is it's defining the relationships between the employees and the clients, namely how much paper an employee sells to a specific client. So over here we have employee ID, we have client ID, and we have total sales. So the employee ID is going to refer to an employee in the employee table. The client ID is going to refer to a client in the client table. And then we're going to define how much in product the client has bought from the employee. So employee 101, for example, that is Michael Scott. Michael Scott has sold client ID 401. Michael Scott has sold Lackawanna County $267,000 worth of product, right? How about this one, 104? So Andy Bernard has sold client number 403, has sold John Daly Law $5,000 in paper products. And so this works with table is able to define how much an employee has sold to a client. And you'll notice over here we have a composite key. And the composite key is employee ID and client ID. And this is actually a special type of composite key because both of these columns are actually foreign keys. So employee ID is a foreign key, right? It relates to the employee table. Client ID is also a foreign key. It relates to the client table. And both of those foreign keys together makes up the primary key of the table. And that is actually a very useful way to define a primary key, because when we do something like this, we can define a relationship, right? So I can define how much product the client has bought from the employee. And that is something that could be really useful to keep track of. So as you can see, like these tables can, either be very simple or they can be very complex. And the more complex your database design or your database schema is, the more complex these tables and these keys are going to have to be, right? So this employee table has a primary key and 2 foreign keys. The client table has a primary key and a foreign key. This works with table has a composite key, both of which are foreign keys. Like it can get very complex, but we can use the primary keys and the foreign keys in order to define different relationships. But really that is just I think a pretty good introduction into kind of how tables work. We talked about rows and columns. We talked about primary keys. We talked about surrogate keys and natural keys, the different types of keys that might map to the real world or not. We talked about foreign keys. We talked about composite keys. And I kind of showed you guys a few different examples of, ways that things might work. So this would be like our, company database. And obviously, we would have a lot more information in here. But this is kind of a good example of how we might define different tables and then define the relationships between those tables in a relational database. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.